my next project, what I was going to make, an adjusting tool for the boring ball I use between centres and the lathe. An adjusting tool so I can use a clock gauge and get precise measurements. I come to put my camera onto my tripod. This is a tripod I bought at a car boot sale. It's a good tripod, nice and sturdy. It's got a releasable plate in the top. I took the plate off my camera to put the camera on the sky hook, and I put the plate somewhere safe, and I spent about 3 hours looking for the bastard thing. It'll be easier to make another one. So instead of making the adjuster for the boring bar, I'm going to make a plate for the camera. I'll fetch it in so you can get a closer look at it. There's a dovetail that locks into there, and the dovetail that goes into there, and that's spring loaded, and that holds a plate in. It's an aluminium one. This is quite a robust tripod. I bought it at the car boot sale, about £6. You can't go around with that. But like I say, I've lost the plate. I spent a fair bit of time trying to find it, and it's going to be quicker just to make another one. The critical thing is the angle in there. What I thought I'd try and use, I'll use my thread. My thread gauges, that's a 55 degree, that's not right. And that's a 60, that's spot on 60 degrees. I thought that would be 60 anyway. 60 degrees. I've got a bit of aluminium plate here that I'm going to use to make it out of. I'll get it out of that. It's a bit of scrap plate. What we'll do, we'll saw the plate roughly to size, and then have a go at machining the dovetail. Already got a nice square colour to work with. It's a nice square, that. It's a more than right one. Belonged to a lad called Billy. Bought it at a car boot sale for probably 50p. Just cut it off by hand. Nothing fancy, just a decent hacksaw frame. It's actually a snap-on one. Only way you ride through and get your knuckles on there. And I've cut a block to size. I've left the lines on, so I want that. The first thing we'll do is a 40mm. So we'll put that in the vise. So we've got 2 square faces to work at, fortunately. We'll put that in the vase. Often what happens when you tighten things up in a vase, they lift up because this jaw lifts. One way to stop that is just simply take aluminium welding wire, put a bit of that in, grip it on there, bed your piece down, tighten it up, and that'll be flat of the jaw, and it won't lift it, it'll still be touching the bottom of the vase. Now we'll put a cutter in, face that off. I've got loads of milling cutters. I've got Harpers and carbide ones. I use these all the time now, they're great. Into a collet, you always use a collet, not a chuck. Chucks off our rolling drills. Got to run these cutters fairly fast. Roughly twice the speed of a conventional cutter. But saying that, I only machine a little bit of aluminium in a home workshop. We're not making bits for NASA. Machining that way into the direction of rotation, conventional milling. And then we'll just take a cut off to get it flat first. Got a power feed on the machine, so I might as well use it. So, wheels locked, cable up. Take a couple of passes. cut on. Power feed on, listen gently. You always make sure the cutter's well clear of the job when you turn the machine off, because sometimes the spindles can drop. Zero my Z-axis. I'll also zero the counter on here, the dial, force of habit. Right, we'll take it out and have a measure. One 40mm. This is 42. We'll change our mind, we'll do it in English. Imperial. 40mm in English. Imperial is 1.6 inches. And we're at 1.6, 1.64. 1.64, so I want 40 thou off that. We'll take 50, so it's a reasonable fit. Put it back in. Show all what chips is out of there. Put it back in. A bit of welding wire. Nip it. Let it down. Right. Right, so we want 50 thou off. It'll take 50 thou and won't cut no problem at all. You can actually run the cutter a little bit faster. Well, I'm not in a hurry. You start running things faster, you need more, you get more heat. Back to the cross, go back the other way, and we're still conventional with it. Yeah, we'll take it out and have a measure. It's 10 thou. 10 thou under 1.6, which is what I wanted. Right, we'll try it in, see what sort of fit we've got. We've got a good fit. Naturally I already tried it, eh? No, I hadn't. Right, so we've got a good fit in there. What we want now is a taper on the end of there. Right, what I'll do, before I do that, I'll square this other end up. Right, I found a 60-degree cutter. It should do a dovetail forward. I've actually machined the other side, and I found if I did conventional milling, I got a straight finish. This is actually clay milling now, pulling the cut and putting a really good finish on. I'll just carry on doing it like that. We're just taking light cuts and showing the aluminium. Put a 40-pound cut on, using the speed. Yeah, it sounds nice. Just putting a good finish on as well. Put a lighter cut on, take it back the other way. You can hear it, it doesn't sound very nice. It's also putting a crap finish on. Create a feed. That's actually fine well in there. You can see it's putting a good finish on. Right, I've got bollocks. Got both ends of the machine now, we'll try it in. That locks it in, that's nice. So it fits into a dovetail in the front, then that locks into the dovetail at the back, and that's what holds your camera. It means you can take your camera in and out quick. Very secure. Got to drill a hole in there now and make a screw to screw into the camera. One thing I've noticed about cameras, all the threads in the camera bases are either quarter Whitworth, and they've small to medium sized camera, and they go up to 3/8 Whitworth on big cameras. I don't know why they use Whitworth, but they do. Like all your pipe threads, even on Japanese machines, American machines, all BSP, taper thread. Of course what will happen is I'll get this bastard finished and the original one will turn up. Anyway, it's filled now, we're in the shop. It's not what I wanted to be doing tonight, but it's something I had to do. So I've spent 3 hours trying to find the original one. It's quicker to make one. There's a recess in there for the head of the screw that goes through there that holds the camera to the top of the plate. The screw's quarter Whitworth. What I'm going to do, I'm going to mark the centre there on the sides of this so I can transfer it across. I'm just going to approximate its centre, which is very similar to guessing, but more accurate. Yeah, so we've got a straight line across there, which is the centre of that hole. Put that plate in, lock it, and we can draw across a line, pick up the centre. Okay, with a good square line across there. Just find the centre of it now, put a pot mark in, and we can drill a hole. Do it the easy way, just join the corners up because it is square. Join the 2 corners up. That is our centre. Right, so I've got a nice mark in the centre of that. Put a nice little pot mark there. And we'll set it up in the lathe, drill a hole, and I want to counterbore it on the other side for a nice big head on the retaining screw. Right, I want to mount this in a vise so I can drill me hole in there. What I'll do, I'll mount on what they call parallels. 2 bits of material are parallel to each other. These are extra from an old height gauge I had, a scrap. Put a little nip on it and give it a gentle bed down with a rubber hammer or a hide hammer. Right, to find the centre of that, what I'm going to use, I'm going to use a wiggler. That's a wiggler. It's got a point on it. Start the machine up. You use something made of metal to push it straight in with your fingers, birds. Push it. See it stop wobbling. And what you do, you eyeball it, two coordinates. It's to the centre punch lock. You can get within the thou with that side using this method, no problem at all. It's not like I couldn't know what I'm doing. That's pretty good. good there. Right, we'll drill a hole through that. I've got to pop them up, but I'll still start it with a centre drill, nice and stiff. Right in the middle of the hole. Go through with a small drill. Just want to all I want to do is transfer the hole to the other side. 4mm drill. See what I could do, I could turn this over and machine the other side with a big milling cutter, but I'm not going to do that. I'm going to mount it in the lathe and do it in the 4-jaw chuck. That's the side where I want machining. So there'll be a recess goes in there. For the head is a screw that holds the camera onto the plate. We'll take the 3-jaw chuck off, put the 4-jaw chuck on, and I'll show you a very quick and accurate way of centering a square bit of stock with a hole in it. This chuck will be tight because I was doing some fairly heavy turning work with it, and back here. Best way to get it off without damaging anything. Spin lock. Here's got a spin lock. Bit of hexi bar. Spin lock here and loosen it like that. If it's not too tight, you can get away with it putting a jaw, set of adjustables or a spanner on one jaw. Don't do that, don't put the chuck key in and hit it with your hand. Hurt your hand. You can crack the inside of there. See, I've got a bit of wood on the bed, so it doesn't matter if I drop the chuck, not hurt anything. Got to make sure the register, the threads of the register on the end of the lathe are nice and clean. Best way to clean it, or easiest way is compress there. Same with the chuck. The chuck will have been cleaned before it was put away the last time. Put a few drops of oil onto the thread and the register. Face is nice and clean. That's the face that butts up against that face, which gives the machine its accuracy. Screw it on and just give it in the up. Right, all we do, put our centre onto the job, a little bit of weight on it. And what I want to do, it's just aluminium, there's no heavy turning going on. I obviously don't want to clamp the jaws of the vise up on that thin edge because it'll damage it. We'll put a little bit of packing under each one of them. Right, so I've got that pushed hard up against the chuck. A little bit of packing under there. Same at the other side. And basically these two are just going to touch it. No load on them at all. It'll be the two jaws where the packing is that do all the holding. Snug each one up and turn, nice and even. start the machine up. You can see the holes running through. And I can put what I call a wiggle bar, a spring with a centre on there with a clock on it, and get absolutely spot on. But for what it's going to be doing, that'll do for me. The bolt that goes through there is going to be quarter width well, so I'll drill a 1/4 inch hole in to start off. See what's cutting nice, it's putting a nice flute out of both sides of the drill. It's a brand new drill. Right, so we've got a 1/4 inch hole in. Now what we're going to do, I'm going to machine a recess in there for the head of the bolt to go into. Right, so we're at 90. That's 100, so that's the full depth, that's as deep as I want it. And that's the diameter I want. Just knock that little rag off. You can see how easy it is to set something up with a 4-jaw chuck quickly. Once you do it with a, hasn't got to be a hole, you can use a centre pop mark, you can do the same thing with that. And like I say, you put a spring loaded bar in with a clock gauge on, which I've shown in earlier videos, and you can really get it accurate. 4-jaw chucks are used nowhere as near as they could be. I mean, I bought this lathe second hand and the chuck's absolutely brand new. It's never been used. See, those 2 jaws are really doing nothing. It's a tool with the packing pieces in. Try to leave that chuck here. It's all the packing pieces in that have been holding it. It's quite reasonable. Happy with that. We've got our hole here. I've got a handy little tool here. Just a drill chuck on a stick. I've just got a nice countersink in the end, just ideal for deburring by hand. Just knock the burrs off. Try it in. All I need now is a bolt maker. Find a centre punch mark.